Today's video will demonstrate how to determine the level of adaptability of a given class design. Hello, I'm James Helfrich. There are three metrics as it relates to class relation design. The first one is adaptability, the second one is alignment, and the final one is redundancy. This video will explain how the adaptability metric is computed, and so we can use this to better design our classes. Adaptability is defined as the suitability of a base class to leverage existing code to represent previously unknown design concerns through the addition of child classes. Now we have several different levels of adaptability. The first one is enabling, and this is the most desirable. Much functionality can be added through small changes, preferably by not adding derived classes or changing the base class, just by making small adjustments to the code that already exists. Next is straightforward. Changes can be made slowly by adding a child class, so the base classes all remained completely unchanged. Next is convoluted, and here convoluted is less desirable than straightforward or enabling because I actually have to modify the base class, which means my testing investment in all the derived classes is going to have to be compromised because the base class is going to impact all the derived classes. Below that is prohibitive. The amount of work is greater than the benefit received. In other words, I have to do a large amount of refactoring before I can even begin adding the new functionality, and that's bad. Closed is enhancement through inheritance are not possible. In other words, no provisions have been made for adding or changing functionality, and I have to pretty much start from scratch. All right, let's take a look at some examples. First of all, I have a video game, and this is going to have three different game entities, a spaceship, an alien, and a bullet. What's the level of adaptability of this? Observe that there is no base class, and so therefore there is no inheritance, and therefore no provision has been made for adaptability. So this is going to be closed by definition. Now, if I have to add a new entity like a missile or a different type of bad guy or whatever, then I'm going to have to duplicate the functionality already exists or do a bunch of refactoring. So I really haven't made any allocation for this kind of change. So it's closed. Next one, I have a bunch of account types. I have a checking, saving, and credit. Now observe that I have four pure virtual functions: input, output, read, and write. And these are going to be implemented in my checking, saving, and credit. What's the level of adaptability of this? What kind of changes do I need to make? Well, presumably I want to add like a stock account or a 401k or something like that. Now, this is going to be prohibitive because the account doesn't actually give me any functionality. All the functionality is implemented in the derived classes. So if I want to create a new account type, I'm going to pretty much have to start from scratch. But it's not closed because I do in fact have inheritance. So is one better than closed? It's prohibitive. The base class is compatible with the derived classes, but the methods are not. Each derived class has its own way of modifying the balance, and so I don't get to leverage any existing work. All right, here's another example. We have the 1980s game called Asteroids, and I have a bullet and I have a rock. I'm going to add a missile too. And how's that going to go when I add missile to this? Well, let's take a look here. This is also going to be prohibitive because the inheritance tree is clearly not closed because there is some inheritance, but the missile takes part of rock and part of bullet. And since I didn't really design the class with this kind of thing in mind, I'm going to have to take some either code from rock and bullet, or I'm going to refactor these guys. Basically, a lot of work is going to have to happen for me just to make a simple change like adding a new bullet. So it's going to be prohibitive. The next one's another video game here, and I have a ship with two derived classes, the default ship and the super ship, right? And then I want to add this new class called a demo ship. What's the level of adaptability here? Well, notice how the attributes of the new class demo ship are already present in the ship. And notice how that all the methods of the demo ship already exist in the base class. Therefore, all I have to do is add a new derived class, and I'm ready to go. That makes this straightforward. This is example 31.1, 31.2, 31.3, and 31.4 in the adaptability chapter of the software design textbook.